morning students, welcome back to our ninth video of quantum mechanical model of atoms. Okay, today we are going to learn a new topic that is called as Pauli exclusion principles. Before that, let me recall once again what are the things we studied in last classes. Okay, last classes we have studied about the energy of orbitals and also of principles. Okay, we have different types of orbitals, s orbital, p orbital, d orbital. Okay, we learned that the energy of orbital, and also we know how to fill the electrons in an orbital with the help of principles. While filling an electrons in an orbital, we must fill from lower level to higher level. Okay, last class I have given an assignment for you. Okay, the assignment is nothing but one problem. Okay, many of them done that problem well, but many of them their problem is not correct answers. Okay, the solution which you are given to the assignment is somewhat good, but sometimes there is many mistakes in that. Okay, so the solutions here. Last classes we have given the assignment for the assignment. This is the solution. Okay, so I have given the energy of electronic ground state, that is a 1 minus 1.31 10 to the power of 6. We have to find that the energy difference between first energy level and the second energy level. Okay, so we have to find the energy difference. This is the second energy level and this is the first energy level. We have to find out the E2 value and we have to find out the En value. This formula, after that we have to minus and give the answer this. Okay, that's why I substitute here. Commonly taken 1.312 into the power of 6 as a common, and 1 by 1 square minus 1 by 2 square, finally give this answer. So this is the solution for last class assignment. Okay, today we are going to start the Pauli exclusion principles. Okay, so this is a very important topic. Some maybe it is asked in 2 more or 3 more questions also. State Pauli exclusion principle. So for that definitions, you have to write this answer. 2 electrons in atoms can have the same set of all values, 4 quantum numbers. Okay, no 2 electrons in an atom can have the same set of values of all 4 quantum numbers. Okay, what is the meaning of this? The Pauli he has given that we have 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Okay, for each electrons in an atom, this quantum number will not be same. There is a unique difference in the spinning of electrons. Okay, let me give an example that you know very well. Let us take a hydrogen atom whose atomic number is 1. Okay, so I am going to write this 1s1. 1s means first addition. This is the principal quantum number. Okay, n equal to 1. This is called principal quantum number, and S is a s orbital. For s orbital, azimuthal quantum number equal to L equal to 0, and if L equal to 0 means definitely M is equal to 0. It has only 1 electrons. I think I have only 1 electron. The spinning of electron is equal to plus of its clockwise directions. Okay, see here, it has only 1 electron, but all the 4 quantum numbers will not be the same. Okay, let us take one more example. Let us take a helium. Whose atomic number is 2. 1 has 2. It holding 2 electrons. Okay, what is the principal quantum number? N equal to 1. What is the azimuthal quantum number? L equal to 0. What is the magnetic quantum number? M equal to 0. Okay, what is the spinning of electrons? Here are 2 spinning of electrons. One is clockwise, another one is anti-clockwise. That is S equal to plus of and S equal to minus of. So students, you must listen that 2 electrons in an atom. Okay, having a 4 set of quantum number is not the same. Definitely there is a spinning difference. Okay, here plus of, here minus of. When you compare with the hydrogen and the helium, this value is entirely similar. Up to this value, you can include this value also. Okay, it will be similar for 1 electrons. But if you have 2 electrons present in an atom, definitely we have anti-clockwise spin is also, sir. So principal quantum number, there is a change in quantum numbers in a spinning of electrons. Okay, that's why the Pauli principle states about two electron in an atom can have the same set of values or not same. Okay, அதாவது ஒரு ஆர்பிட்டல்ல ரெண்டு எலக்ட்ரான்ஸ் இருக்குது அப்படின்னா அந்த ரெண்டு எலக்ட்ரான்ஸ் வந்து 4 குவாண்டம் நம்பர் இருக்கு அப்படின்னு சொன்னீங்கன்னா 4 குவாண்டம் நம்பர் வந்து பார்த்தீங்கன்னா டிஃபரன்ஸ் இருக்குது, எல்லாம் சேமாவே இருக்காது. எது டிஃபரன்ஸ் இருக்கு அப்படின்னு கேட்டால் கண்டிப்பாக ஸ்பின்னிங் ஆஃப் எலக்ட்ரான் டிஃபரன்ஸ் இருக்கு. ஏன்னா ஸ்பின்னிங் ஆஃப் எலக்ட்ரான்ஸ் ஒரு எலக்ட்ரான்ஸ் வந்து கிளாக் வைஸ் சுத்தம் ஆன்டி கிளாக் வைஸ் சுத்தம். ஸோ பிளஸ் ஆஃப் ஒன்று மைனஸ் ஆஃப். ஸோ தட் இஸ் எ சேஞ்ச் இன் தட். ஓகே, you can go through your textbook. There is a tabular column is given for each electron. Spinning will be there. Okay, let us take first electron. First electron is one electron. First electron is n equal to 1, l equal to like that. Spinning is given. Second electron, third electron. So this is the second electron. Definitely third electron. Okay, what is the value? What is the principal quantum number? What is the azimuthal quantum number? And what is the spin quantum number? What is the magnetic quantum number? All 4 quantum number values are given in your tabular column in your textbook. Okay, so students, you have to go through the tabular column very carefully, write in your class of notes. Okay, so sometime they will be asking one more questions. Suddenly they will ask one more question. What is the fifth element of a carbon? So fifth electrons, write the 4 quantum numbers for fifth electrons of carbon atom. That means you have to write it. See, carbon atomic number is 6. Total 6 electrons are there. 1s2, 2s2, 2p2. Okay, so it is here 2, 4, 5, 6. This is the 6th electron. It belongs to Px, Py, Pz. So it belongs to Py. For 6th electron, you have to write the 4 quantum numbers. 4 quantum numbers means what? What is the quantum number for 6th electron? It is a 2Py. So 2 is a principal quantum number. What about azimuthal quantum number? It belongs to P orbital. What is the azimuthal quantum number? Value is L equal to 1. We know that once again I repeat here. For azimuthal quantum number, we have the value for 4 orbital. For s orbital 0, for p orbital 1, d orbital 2, and f orbital 3. Okay, so p orbital is 1. Magnetic quantum number is equal to, we know this is a -1, 0, 1. Okay, minus 0. Okay, then what about spin quantum number? Spin quantum number only 1 electrons are there. So it belongs to plus of conditions. Okay, so that's why here magnetic quantum -1, 0, 1. Likewise, in exam, maybe 1 or 2 more questions will be asked. What is the 4th element of carbon? What is write the 4 quantum numbers for 4th electrons in carbon atom. Likewise, many questions will be asked for you. Okay, so keep mind that the Pauli exclusion principle is very important. No, it's really important. No 2 electrons in an atom having 4 set of quantum numbers will be same. இல்லையா, அது சேமாக இருக்குன்னு சொல்லவே முடியாது. அப்படின்னு சொன்னால் யாரும் கேட்டால் பாலி எக்ஸ்க்ளூஷன் பிரின்சிபல்ஸ். ஒரு ஆட்டத்தில் 2 எலக்ட்ரான்ஸ் இருக்குது. அந்த 2 எலக்ட்ரான்ஸ் வந்து பார்த்தீங்கன்னா 4 குவாண்டம் நம்பர் சேமாக இருக்கிறது பார்த்தா இருக்காது. ஏதாவது ஒரு டிஃப்ரென்ஸ் இருக்கும். அந்த டிஃப்ரென்ஸ் எது இருக்கும் அப்படின்னு கேட்டால் ஸ்பின்னிங் ஆஃப் எலக்ட்ரான்ஸ் தான் இருக்கும். ஓகே, ஸ்பின்னிங் பார்த்தீங்கன்னா ப்ளஸ் ஆஃப் இருக்கும், மைனஸ் ஆஃப் இருக்கும். ஸோ டெஃபினெட்லி தெர் இஸ் ஏ சேஞ்ச் இன் தட். ஓகே, திஸ் இஸ் கால்ட் அஸ் வாட்? பாலி எக்ஸ்க்ளூஷன் பிரின்சிபல்.
Pauli's exclusion principle. In 1925, Pauli put some restrictions on assigning quantum number to electron in the orbital. Statement: no 2 electrons in an atom can have same set of 4 quantum numbers.
This means that 2 electrons in an atom can have same n, l, and m value, but different spin quantum number.
Example: helium. He atomic number 2. It has 2 electrons. Quantum numbers for first electron: n is equal to 1, l is equal to 0, m is equal to 0, and s is equal to plus half. Quantum numbers for second electron: n is equal to 1, L is equal to 0, M is equal to 0, and S is equal to minus half. Application. Useful to determine the maximum number of electrons in a main shell orbit is equal to 2n square. Subshell is equal to 2 of 2L plus 1.
Next topic we are going to see Hund's rule, maximum multiplications. Okay students, next topic is Hund's rule of maximum multiplicity. So this is also a very important 3-mark question. Definitely those type of questions will be asked in another public exam. Okay. So Hund's, what are the meaning of that maximum multiplicity? Okay. The electron pairing in a degenerated orbital does not take place until all the available orbitals contain one electron each. Okay. Before going to learn this one, but we know what is in the degenerated orbitals. Degenerated orbital means let us take a p orbital having a 3 suborbital that is called as px, py, pz. Let us take a d orbital. It is having a 5 below that dxy, dyz, dxz, dx square minus y square, dz square. Likewise, a f orbital. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Some degenerated orbitals are there. Okay, here 3, here 5, here 7. These are called as degenerated orbital. Degenerated orbital means whose orbital having the same energy. Okay, for example, if you consider px and py and pz, px and py, pz, all these orbital having the same energy in a ground state. Okay, if any external source is given, any extra energy or external source is given, the energy difference will be takes place. Those things are studied in last section itself. Okay, but we know what is degeneracy. Degeneracy means p orbital having a 3 suborbital having the same energy. It is called as a degeneracy. Likewise, d and f. See, while filling an electrons in an orbital, we know that Afau has given an idea to fill electrons in an orbital from lower level to higher level, but he doesn't tell us about how to fill the electrons in degenerated orbitals. Okay, that's very important. So here Hund's explain about how to fill the electrons in a degenerated orbitals. Here, for example, p orbital having a 3 suborbital, d having 5, and f having 7. While filling d orbital in p, while filling electrons in p orbital or d orbital f orbital, first you should fill singly, then only you should fill parallel. Okay, let me see one example. If you take an example for fluorine, okay, fluorine whose atomic number is 9. Okay, so atomic number is 9 means first shell carrying 2 electrons, second shell carrying 7 electrons. Okay, 2, 7. Okay, here we are going to write the electronic configuration 1s2, 2s2, 2p5. Okay, this SR will having 2 electrons. This SR will having 2 electrons. Let us take this p orbital. P orbital having 5 electrons. This is 2px, 2py, 2pz. Having 5 electrons. 1, 2, 3, 4, and 5. Okay. See students, we have to fill this electron first singly, then one parallel. See, this is a correct method. But when you can if you fill like this is a wrong method. Okay. That means the degenerated orbital first filled with the single electron, then only it should be filled with the pair. Okay. For example, if you take a carbon atom whose atomic number is 6, 1s2, 2s2, 2p2. So this is the degeneracy orbital. This is 2px, 2py, 2pz. We have to fill this 2 electron in this orbital. Okay. You should not fill like this. So this is a wrong method. According to the Hund's rule, those electrons should be filled first singly, then they should be paired. Okay, this is a correct method for filling of electrons in an orbital. Let us see one more example: oxygen, atomic number 8. Okay, 1s2, 2s2, 2p4. So we are going to fill this orbital, p orbital. So this we are having 4 electrons. So we have to fill like this. This is a correct method. So this is not a correct method. So this is a wrong method. This is a correct method. That means the electrons should be filled in the orbital first singly, then it should be paired. This is called as a Mohs rule. Okay. So the definition is given like that. The electron pairing in the degenerator orbitals does not take place until all the available orbitals contain 1 electrons each. ஒரு சிங்கிளா ஃபில் பண்ணிட்டு தான் பண்ண போறீங்க பேர் பண்ணணும் ஒரு ஆர்பிட்டல் எலக்ட்ரான்ஸ் நீங்க ஃபில் பண்றீங்க இந்த மாதிரி டிஜெனரசி ஆர்பிட்டல் ஃபில் பண்ண போறீங்க அப்படின்னா டிஜெனரசினா இந்த மாதிரி 3 ஆர்பிட்டல் இருக்கு பி ஆர்பிட்டல் இருக்கு டி க்கு 5 சப் ஆர்பிட்டல் இருக்கு எஃப் க்கு 7 இருக்கு அப்ப டிஜெனரசினா எனர்ஜி வந்து சேமா இருக்கும் 3 ஆர்பிட்டல் இருக்கும் புரியுதுங்களா ஏதாவது எக்ஸ்டர்னல் சோர்ஸ் கொடுக்கும்போது தான் எனர்ஜி வேரி ஆகும் unless until this orbital all this orbital having the same energy that is called as a degenerator orbitals இதுல நீங்க எலக்ட்ரான்ஸ் ஃபில் பண்ணனும் அப்படினா முதல்ல சிங்கிளா ஃபில் பண்ணிட்டா நீங்க என்ன பண்ணணும் பேர் பண்ணணும் அதுதான் வந்து Ohm's rule of maximum multiplicity. Okay, next topic we are going to learn how to write the electronic configuration of an atom. Okay, so it's the Ohm's rule. By filling an electrons in p orbital, 4th electron here, 6th electron here, 8th electron. Okay, 4th electron should comes here. I mean, it should be filled. First 3 electrons should be filled singly, then 4th electron should be paired. Here, 5 electrons should be filled singly, and 6 electrons should be paired. Here, 7 electrons. 7 electrons mean 1, 2, 3, 4, 5, 6, 7. 7 electrons are singly filled. 8th electron is going to be paired. That's why Ohm's rule explains about how to fill electrons in a degeneracy orbitals. Okay, let's.
Pairing of electrons take place only when all the available degenerate orbitals in a given subshell are filled with 1 electron each. Explanation. Subenergy level P has 3 orbitals, px, py, and pz. These are filled with 1 electron first and then pairing takes place. Examples. Boron B, atomic number Z is equal to 5. Electronic configuration is equal to 1s2, 2s2, 2px1. 5th electron enters in 2px orbital. Carbon C, atomic number Z is equal to 6. Electronic configuration is equal to 1s2, 2s2, 2px1, 2py1. 6th electron enters in 2py orbital. Nitrogen N, atomic number Z is equal to 7. Electronic configuration is equal to 1s2, 2s2, 2px1, 2py1, 2pz1. 7th electron enters in 2pz orbital. Oxygen O, atomic number Z is equal to 8. 1s2, 2s2, 2px2, 2py1, 2pz1. After filling 2px, 2py, 2pz subshells with 1 electron, pairing in 2px takes place. This is called Hund's rule. Anomalous configuration, chromium and copper. Half-filled and completely filled degenerate orbitals have symmetrical distribution of electrons in them, and therefore they are more stable. Example 1. Chromium. Atomic number Z is equal to 24. It should have the configuration Aragon 3d to the power of 4, 4s square. But actually it has Ar 3d to the power of 5, 4s to the power of 1. This configuration gives half-filled orbitals. These half-filled orbitals give stability to atom Example 1. Copper. Atomic number Z is equal to 29. It should have the configuration argon 3d9 4s2. But actually it has argon 3d10 4s1. This configuration gives completely filled d orbitals and half-filled s orbital.
Next topic is the electronic configuration of atoms. This is a very important topic. How to fill electrons in an atom. Okay. So we must know how to write electronic configurations. This electronic configuration is full and full based upon Hopf principle, Hund's rule, Pauli exclusion principle. While writing an electronic configuration in an atom, we must follow those three principles: Hopf, Hund's, and the Pauli exclusion principles. Okay, let me see what is meant by electronic configuration of an atom. The distribution of electron in various orbitals of an atom is called its electronic configurations. ஒரு ஆட்டத்துல நிறைய ஆட்டம்ஸ் இருக்கு, வேரியஸ் ஆட்டம் இருக்கு. Various atoms, how we are going to distribute the electrons in an orbitals. Okay, this is called as electronic configurations. Okay, let I give you a few examples. Before that, let me write the Hopf principles. The help of Hopf principles only, it is very useful for Hopf principles. Very useful to write the electronic configuration. Let us take 1s, 2s, 2p, 3s, 3p, 3p, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s. Okay, let me start Hopf principle. Okay. Okay. So this is called as Hopf principle. With the help of this Hopf principle, we are going to write the electronic configuration of an atoms. Before that, let me written as a general electronic configuration can be written as formula NLX. Okay, N is a principal quantum number, L is asymptotic quantum number, and X is a variables. Okay, with the help of this formula, let me write one example like hydrogen, whose atomic number is 1. Write the electronic configuration of hydrogen. 1s1. 1 is a principal quantum number. L is an orbitals, which orbitals belongs to. Okay, and X is a variables. Okay, let us take an atom. This is a hydrogen atom having only 1 electron. Because whose atomic number is 1, it having 1 electron. This is the first shell, so I can put 1. This 1 electron comes from present in S orbital, so I can put S. Only 1 electrons are there. That's why it's called as 1s1. Okay. Likewise, 1s1, 1s2, 2s2, 3s2, we are going to follow. We are going to write the electronic configuration on the basis of Hopf principles. Let me give one example, small example. Take an example for carbon atom. Carbon atom whose atomic number is 6. With the help of Hopf principle, we are going to write. See, first S can hold only 2 electrons. S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. This is the basic principle, so you know that. With the help of this Hopf principle, let me start writing electronic configuration for carbon atoms. See, 1s2. Okay. Then it comes to what? 2s2. Then it comes to 2p. 2p can maximum 6 electrons. But here, only I already written 4 electrons here, remaining 2 electrons are there. That's why I can put 2p2. Okay. This is the electronic configuration for carbon atoms. Let me write one more example. Electronic configuration of neon, whose atomic number is 10. So start with the 1s2. Okay, then it comes to 2s2. Then it comes to 2p6. So 2 plus 2, 4, 4 plus 6, 10. Electronic configuration is over. Then we start writing potassium, whose atomic number is 19. Okay, start with the Hopf principle. 1s2. Then 2s2. Then 2p6. Then 3s2. Then it comes to 3p6. Okay, count it. 2 plus 2, 4, 4 plus 6, 10, 12, 18. Remaining one more electrons are there. Okay, 3p is finished. Then this comes from 4s2. You know that, sir, 3p next 3d, no. You know that comparing 3d and 4s energy level is very, very less. 3d level is very, very high. By using the formula m plus n that you studied in last classes itself. Okay, so that's why the electrons are enters into 4s1. This is the electronic configuration of the potassium. So likewise, many examples are given in your textbook with a tabular column. Go through the tabular column. That tabular column should be written into your class report. Okay, whenever I am giving assignment, after finishing the session, I am going to give you assignment. In that assignment also, after finishing the assignment, you should write this tabular column in your textbook. Take a photo and send it to your WhatsApp group. Okay, this are the electronic configurations method. Okay, there is a few exception cases are there. What are the few exception cases? Actually, we are expecting a certain electronic configurations, but it changes. There is some difference takes place in the expectations. Okay, actual electronic configuration can be. When you are expecting electronic configuration, this changes the actual electronic configuration. For example, if you take a chromium, whose atomic number is 24. So here I am writing the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4, 10, 12, 18. 18 next it comes to 4s2, 20, then 3d4. 3d4 is 24. So above principle 1s2, 2s2, 2p6, 3s2, 3p6. It comes for 4s2, then 3d4. Okay, it is 4s2, 3d4. So this is a electronic configuration for chromium. That's why I did that. Sir, I am expecting this electronic configuration. You may ask the question, sir. You are always saying that the comparing 3D and 4s energy level is very less. So you should come here and 3D should come there. No problem. You can write as it is. But why I am writing like this means the series is same. See, first shell, second shell, third shell, fourth shell, likewise. But while filling an electron, you have to fill the electron from 4s2, then you come to what? 3D. First you have to fill the electrons in 4s2. Then remaining extra electrons only enters into d orbital. That's why this chromium belongs to d block element. Why? What is in the d block elements? In 12th standard, we are going to learn a separate lesson for D block, a separate lesson for S block and F block. There may ask the question, what is in the D block element? The extra electrons. Extra electrons means what? While filling an electronic configuration, while filling an electrons in an atom, the extra electrons are enters into D orbital. That means the last electrons are present in the D orbital. That's why they are called as a D block element. Definitely chromium belongs to D block element. Why I am telling you? See here, after writing this electronic configurations, after finishing this 3p6, electron jumps to 4s2. They fill the 2 electrons there. The remaining 4 electrons comes to D orbital. That's why they are called as a D block element. Okay. So you may not have any confusion here. நீங்கள் குழப்பமே தேவையில்லை. நீங்கள் சொல்லலாம் சார், நீங்கள் தானே சொன்னீங்க 3p அப்புறம் 4s2 தானே வரணும், நீங்கள் ஏன் 3d போடுறீங்க? அதெல்லாம் ஒன்றும் பிரச்சனை கிடையாது. நான் சீரியஸ் வந்து 6வது மாதம் போட்டிருக்கேன். பட் ஆனால் ரியலாக அப்பா பிரின்சிபல் பிரகாரம் எனர்ஜி லெவல் பிரகாரம் நம்ம 3p6 அப்புறம் எலக்ட்ரான்ஸ் எங்கே ஃபில் ஆகும்? 4s2 ஃபில் பண்ணிட்டு தான் எக்ஸ்ட்ரா எலக்ட்ரான்ஸ் எங்கே வரும் அப்படின்னு கேட்டால் dr வரும், 3dக்கு வரும். இதுதான் எக்ஸ்பெக்டட். நம்ம எக்ஸ்பெக்ட் பண்ணுற கான்ஃபிகரேஷன் இதான். இது அப்பா பிரின்சிபல் பிரகாரம் எழுதும்போது இதுதான் கரெக்டான கான்ஃபிகரேஷன்ஸ். ஆனால் திடீர்னு மாறி போகுது. புரியுதுங்களா இல்லையா? நான் மாறி போகுது. எப்படி மாறுது அப்படின்னு கேட்டால் 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. அப்படின்னா அர்த்தம் ஒரு இடத்துல இங்கே ஜம்ப் ஆகி இருந்துச்சு 3d5 இருந்துச்சு. ஆனால் கூட்டி பாருங்க 4, 10, 12, 18, 18 plus 1, 19, 19 plus 5, 24. Actual electronic configuration is same as that. But there is a difference on that. Difference is there. We are expecting this electronic configuration with the help of Hopf principle, but we are getting this type of configuration for few elements like the chromium and the copper. Let us take a copper whose atomic number is 29. Okay, I am going to write the electronic configuration 1s2, 2s2, 2p6, then 3s2, then 3p6. Okay, 3p6 is finished. We have to write 4s2. Okay, 4s2. Then check பண்ணி பாருங்க 2 4 10 12 18 18 plus 2 20. Okay, then 3p6 okay, then see 2 4 8 2 4 10 12 18 20. Remaining I have to put 9 electrons are there, so I can put 3d9 because D are maximum 10 electrons. So this is a expected electronic configuration with the help of a Hopf principle. But actually what happens over here, the electronic configuration is changed as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. That means 1 electron jump from here to here. Okay, so here also while counting this, we'll get it 29, 10, 12, 18, 28, 29. Okay, this is the actual electronic configuration of the copper. This is the expected electronic configuration. This is on the basis of Hopf principle, we are getting this type of configuration. But there is a slight changes there. Why these changes happens? Okay, you know that completely filled and the completely off-filled orbital have more stable. Okay, completely filled and other parallel. Let us take a d orbital. This is 3D parallel. 3D. This is a d orbital. How many electrons are there? 5 electrons are there. 1, 2, 3, 4, 5. 5 electrons are there. Here, d orbitals also. How many electrons are there? 10 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is completely off-filled. Off-filled. This is completely filled. Okay, this is completely off-filled. This is completely filled. Completely off-filled orbital and the completely filled orbital has more stable. Okay, in order to attain a more stable for d orbital, the electrons jump from here to here. So the electronic configuration changes 3d5. So 3d5 here 3d10 has more stable. That's why electronic configuration is changing from expectation. From expected electronic configuration, there is a change because of not to attain a stable electronic configurations. Chromium, copper, stable electronic configuration அடையிறதுக்கு கோசம் ஆக்சுவலா இருக்கக்கூடிய எலக்ட்ரானிக் கான்ஃபிகரேஷன்ல சேஞ்சஸ் இருக்கு. 3d4 வந்து 3d5 ஆ மாறி போகுது, 3d9 வந்து 3d10 ஆ மாறி போகுது. ஏன்? அது ஸ்டேபிளான எலக்ட்ரானிக் கான்ஃபிகரேஷன் அடையிறதுக்கு கோசம் எலக்ட்ரான்ஸ் வந்து எஸ்ல இருந்து இங்க ஜம்ப் ஆகி வந்துருச்சு. 4s வந்து எலக்ட்ரான் ஜம்ப் ஆகி 3d க்கு போயிருக்கு. ஓகே, அதனால 3d5 ஆகி போகுது, 3d10 ஆகி போகுது. இந்த ஆர்பிட்டல் வந்து ரொம்ப ஸ்டேபிள் ஆகி போகுது. ஜஸ்ட் மோர் ஸ்டேபிள் இந்த ஆர்பிட்டல் 3d10 3d5. ஓகே, அதே போல வந்து எஃப் ஆர்பிட்டல் பாருங்க. எஃப் ஆர்பிட்டல் பார்த்தீங்கன்னா நமக்கு வந்து 7 ஆர்பிட்டல் 1 2 3 4 5 6 7. இதுல பாத்தீங்கன்னா 7 எலக்ட்ரான்ஸ் இருந்ததுன்னா 7 14 7 எலக்ட்ரான்ஸ் பாத்தீங்கன்னா 1 2 3 4 5 6 7. இது கம்ப்ளீட்லி ஆஃப், இது ஸ்டேபிள். 14 கம்ப்ளீட்லி ஃபில் ஆயிடும், அதுவும் ஸ்டேபிள். ஓகே, லைக்வைஸ் pr எடுத்தீங்கன்னா p3 வந்து ஸ்டேபிள், p6 is also stable. p3 is completely off filled, p6 வந்து completely filled. ரெண்டுமே more stable electronic configurations. ஓகே, ஸோ நம்ம எலக்ட்ரானிக் கான்ஃபிகரேஷன் எழுதணும் அப்படின்னு சொன்னீங்கன்னா நம்ம வந்து ஃபர்ஸ்ட் யாரை மைண்ட் பண்ணணும் அப்படிங்கிறதா ஹாஃப் பிரின்சிபல்ஸ். அவர் வச்சு தான் எலக்ட்ரானிக் கான்ஃபிகரேஷன்ஸ் இந்த டயக்ராம் வச்சு எவ்வளோ பெரிய ஆட்டம் இருந்தாலும் சரி, அட்டாமிக் நம்பர் பெருசாக இருந்தாலும் சரி, we can easily write this. Okay, இது ஸ்டூடெண்ட்ஸ் ட்ரை ஃபார் மெனி ஆட்டம்ஸ், நிறைய ஆட்டத்துக்கு இந்த மாதிரி எலக்ட்ரானிக் கான்ஃபிகரேஷன் ட்ரை பண்ணி பாருங்க ஹாஃப் பிரின்சிபல் பேஸ் பண்ணி. அதே நேரத்தில் எலக்ட்ரான்ஸை ஃபில் பண்ணும்போது கீப் இன் யுவர் மைண்ட் தட் ஆல் எக்ஸ்க்ளூஷன் பிரின்சிபல்ஸ் அண்ட் ரூல்ஸ் இருக்கும். ஓகே,
You'll need to be familiar with the structure of an atom before going any further, and you may wish to look at the lesson Parts of an Atom, Their Charge and Their Mass first. Electrons are arranged in energy levels or shells around the nucleus of an atom. The actual orbit shapes are a bit too complicated to cover in such a short lesson, but on average, the orbital radius increases as the energy levels increase. In our diagrams, the shell nearest the nucleus is going to represent the lowest energy level or shell, and we draw a circle to depict each shell. We use a dot or a cross to represent each electron, and we'll represent the nucleus by the chemical symbol. Each electron in an atom is in a particular shell, and the electrons must occupy the lowest available shell nearest the nucleus. So, when we are drawing the electron configuration, we have to fill up each shell in turn, starting with the lowest. We'll take a lithium atom as an example. With an atomic number of 3, it must have 3 electrons to balance the positive charge of the 3 protons in the nucleus. It's worth remembering that the atomic number tells you the total number of electrons in a neutral atom. So, we put the first electron into the first shell, and the second. However, this shell can only contain a maximum of 2 electrons. That's one of the rules that you need to remember. The third electron, therefore, must go into the next shell, which we draw as a larger circle around the outside of the first. And that completes the electronic configuration of a lithium atom. The same process of filling up shells applies to larger atoms. You always start with the lowest available shell, and whenever a shell is full, the next electron to be added goes into the next shell. And that's pretty much it. All you need to know is how many electrons can occupy each shell, and at this level, you only need to know the rules for the first 20 elements. The maximum numbers are as follows. The first shell can contain a maximum of 2 electrons. The second shell, up to 8 electrons. The third shell also has a maximum of 8 electrons. And the 19th and 20th electrons go into the fourth shell. And this would actually represent a calcium atom. Note that as we fill up each level, we've been drawing the electrons evenly spaced out on each shell. This is to keep the diagrams tidy and make it easier to count the electrons. And what's more, there's a shorthand way of writing this down. 2, 8, 8, 2. The first number represents the inner shell or lowest energy level. The full stop shows how the electrons are separated between the shells. The second number tells us how many electrons are in the next shell, followed by the third and fourth shells. And so now it's your turn. I'd like you to draw the electron configuration of a carbon atom. Pause the video, find a piece of paper and have a go. And here is what it should look like. It has a full first shell and 4 electrons in the outer shell. Did you get it right? Now, how would you write the electron configuration in numbers for this atom? Pause the video again or rewind if you need to have a think about this. The answer is that it would be written 2.4. And now that you have covered the basics of drawing electron configurations, you'll be ready to tackle our lesson, Electron Configurations of the First 20 Elements.
ஒரு டாபிக் பார்க்குறது ஒன்று வந்து பாலி எக்ஸ்க்ளூஷன். பாலி எக்ஸ்க்ளூஷன் பிரின்சிபல் சொன்னால் 2 எலக்ட்ரான் ஒரு ஆட்டம் இருந்ததுன்னா 4 குவாண்டம் நம்பர் சேமாக இருக்காது. ஓகே, ஸ்பின்னில் கண்டிப்பாக சேஞ்சஸ் இருக்கும். அது வந்து பாலிஸோட கான்செப்ட் இல்லையா? முன்ஸ் என்ன சொல்கிறேன் அப்படின்னு கேட்டால் டீஜெனரேட்டட் ஆர்பிட்டல் அப்படின்னு இருக்கும். டீஜெனரேட்டட் ஆர்பிட்டல் பிடிஎஃப் இதெல்லாம் வந்து சப்பார்டினேட்ஸ் இருக்குது. அதான் டீஜெனரேட்டட் ஆர்பிட்டல். அதில் எலக்ட்ரான்ஸை ஃபில் பண்ணும்போது முதல்ல ஆர்பிட்டல் சிங்கிளாக ஃபில் பண்ணி தான் பேர் பண்ணணும் அப்படின்னு சொல்லுவார். யாருன்னு கேட்டால் முன்ஸ். ஓகே, எலக்ட்ரானிக் கான்ஃபிகரேஷன் எப்படி நீங்கள் எழுதுவீங்க அப்படின்னா, எலக்ட்ரானிக் கான்ஃபிகரேஷன் எழுதுறதுக்கு எனக்கு யார் தேவைப்படுறாங்க? அப்பாவும் தேவை, பாலியும் தேவை, முன்ஸும் தேவைப்படுது. ஸோ அதை வச்சு தான் பண்ணுறேன், நான் எலக்ட்ரானிக் கான்ஃபிகரேஷனை எழுதுறேன். இந்த பிரின்சிபல் வச்சு ஈச்சன் எப்படி ஆகுது எலக்ட்ரானிக் கான்ஃபிகரேஷன் எழுதுறேன். ஓகே, சில ஆட்டம்ஸ் பார்த்தீங்கன்னா நம்ம எக்ஸ்பெக்ட் பண்ணுற எலக்ட்ரானிக் கான்ஃபிகரேஷன் அப்பா பிரின்சிபல் மூலமா எக்ஸ்பெக்ட் பண்ணுற எலக்ட்ரானிக் கான்ஃபிகரேஷன் இருக்கும். ஆனால் தின்னு பார்த்தா அது மாறிடும். ஏன் அந்த மாற்றம் வருது அப்படின்னு கேட்டால், அந்த ஆட்டம் வந்து அந்த ஆர்பிட்டல் ஸ்டேபிளாக ஆகிறது ரோஷனாக போய் எலக்ட்ரான்ஸ் போய் வாங்கிட்டுனா போயிடும், ஸ்டேபிள் ஆகிடும். அதுதான் இந்த கேசஸ். ஓகே ஓகே ஸ்டூடெண்ட்ஸ், டுடே we are going to 3 topics. Go through the 3 topics very carefully. Do the assignments very clearly. Keep on telling that the few students are not at all doing their assignment. Okay, so each and every teachers are pointing on you, and they are writing the names those who are not completed the assignment. Okay, so do the assignment very carefully. Thank you, students.